Hello, everyone. I hope that you are doing well and that you have enjoyed your summer break. Welcome to the first meetup of iLadies Paris organized in 2022, after like being inactive since 3 years ago. So iLadies Paris is a local chapter of a worldwide organization, iLadies Global. As you can see, iLadies chapters have been active across different regions, and the number of chapters is always growing. iLadies Paris aims to dedicate more support towards improving gender diversity in the R community and to support all our users all over the world. I know that because I know today that you have people joining us from different corners of the world. So it was founded in 2016, and it's currently running by me. So my name is Muna Bilaid. I'm a business intelligence consultant at Prime Analytics. I'm active in various communities of practice. I'm passionate about volunteering, coding, and sharing knowledge. So I'm also a member of iLadies Global team. So what about iLadies Paris on social media? You can find us on Twitter and also on our meetup group. So this is where we share about our future meetups. You have also a GitHub organization. So this is where all the materials of the previous meetups are like publicly available. And this is where we are going to store the materials of our future meetup. And you are also going to share the recording videos on our YouTube channel. So please make sure to follow us. You are also active on LinkedIn, Instagram, Facebook. And what about our WhatsApp group? So this is where you can get closely in touch with the iLadies community members through discussions. And this is where you can learn more about each other and also learn from each other. And this is important and improve our knowledge. You can maybe share about projects that you are working on using R. So please don't hesitate to join us and to introduce yourself there. I will make sure to share with you the links in the chat in a bit. What about our upcoming meetups? We are pleased to collaborate with other chapters, other communities like iLadies Cologne, PyLadies students at PyLadies Munich in organizing a joint meetup on September 30 about the use of Plot9 in Python. So Plot9 is a visualization library very similar to the ggplot2 library in R. By the end of the workshop, we'll be familiar with basic Plot9 concepts and create visuals using data provided by Tidy Tuesday. This session will be animated by Tanya Shapiro, and you can right now register for the meetup on our meetup group. We'll be also delighted to be hosting Tanya Shapiro one more time on October 13 during a session that is dedicated to beginners about data visualization using ggplot2 in R. So this meetup is not published yet. You are also planning to organize some in-person meetups, so stay tuned. We are all welcome to join us. What about today's meetup? So this meetup will serve as an introduction to the Tidyverse, and we learn how to effectively organize, transform, analyze data in R. And therefore, we are so pleased to be hosting Meghan Hall. So she has spent over 7 years as a data professional in higher education. She also has experience in sports analytics as an ongoing contributor to the public community. And also she previously worked as a data scientist. She's dedicated to our education and particularly for beginners and frequently delivers talks, workshops, and classes. I'm sure we'll learn a lot from her today. So last thing before you start, as you know, so the session is recorded. If you prefer not to be recorded, just please turn off your video. If you have any question, please leave a message in the chat box. And before you leave, I will have a form that I will share with you later. So please don't hesitate to give us your feedback about the question. Yes, you have a code of conduct. So please, let's keep making this place a welcoming and friendly community for everyone. Thank you all for attention, and the screen is yours, Meghan.
Thank you so much. Thank you so much for inviting me and for that lovely introduction. Let me get my screen shared here. All right, I assume everyone can see my screen here. Yes, thank you. I'm so excited to speak here with today with Our Ladies Paris, talking a little bit about the Tidyverse, my personal favorite collection of packages, which we will certainly get into. So just to give kind of a quick, you took care so nicely of my intro, so I don't really need to do it. But yes, I have been using R myself for many years professionally. I use R all day long. I work in higher ed in data, and I also have some experience in sports analytics. And also on the side, I do workshops like this for our ladies groups and other our user groups and conferences, etc. Because I myself am a self-taught programmer. I don't have like a computer science degree. I did not do this. I did not start coding when I was in college and everything. I was more of a kind of later convert and taught myself R. Again, thanks to all of the resources that are available in the R community, which is really one of the things that drove me to R. So I personally feel a lot of gratitude for so much of the R community, particularly the R ladies community, which is really wonderful. And so I like to, again, give back. I still feel very close to being a beginner myself. There's still things I'm certainly learning every single day. And so I, again, feel a special kinship toward people who are learning R, teaching themselves R, and kind of want to help where I can. So in today's workshop, you can code along on your own if you want to, but you don't have to. Due to the kind of the time constraints we have, kind of the logistical constraints, I won't be able to address any like individual debugging questions like throughout the workshop, like this code isn't working for me, I don't know why. I'm happy to talk about that later in the workshop. I will share all of my contact information. You can email me. I'm also on Twitter. And all these materials are publicly available. So if you want, you can just listen, kind of see as I code along through these examples, and then kind of work through and look at the code on your own. Or again, all the materials are available. The link is here on the bottom of the slides, and you can, again, go through it kind of with me if you want to. And there also won't be, and along with that, we won't be like breaking out and saying, oh, you have 10 minutes to complete this exercise, just in case, because I don't know what everyone's Tidyverse levels are. I want to make sure everyone gets a lot of things out of this workshop. So as I mentioned, all the workshop materials are publicly available. The website link is here at the bottom of the screen. I can show you what that looks like. There's a companion website for this workshop. It's the same things that we're going to talk about. It just kind of goes through the code, in a slightly more verbose way, different way than I'll be doing on the slides. There's also links to the workshop slides themselves if you want to check that out. And also just a straight code file that has just the code of what we're going to do in today's workshop. So no need to like panic and write down any syntax that you might miss. You will absolutely have access to all of this. And I found out that we are recording the workshop, which I believe will be available on the Our Ladies Paris YouTube channel. So again, if I can't imagine this would happen, but if I say anything that you really need to remember, you will have multiple ways to access that information afterward. Lastly, questions. So as I mentioned, just due to kind of the nature of this workshop, because we're not together, we don't have that much time, I don't know everyone's levels, I won't be able to address very specific debugging questions for your own code unless we have some time at the end, but I am more than happy to address any kind of broader questions about anything that we're talking about in the workshop. I'm going to certainly save some time at the end, and I'm also going to take a little bit of a mini break, probably like halfway through, just to, if you want to, you can stretch your legs, get a snack, get some water, whatever, and I'll also address any questions that come up. So if any questions come up while I'm talking, you can just drop them in the chat, or again, I will solicit questions both kind of at a little break in the middle and also at the end. And as I mentioned before, I am going to share my contact information. at the end. So again, you feel free to, if you think of a question later, I'm available if you want to email me or find me on Twitter. If there's a question you are too embarrassed to ask, which I hope is not true. But I understand that happens. If you think it's too beginner of a question, I promise you it's probably not. And someone also has that question. But again, if you want to, you can also, there is access to me available after the end of this workshop. All right, so I assume if all of you are here interested in a Tidyverse workshop, I don't need to do too much evangelizing about R, but I can't resist doing just a little bit. R is so great because it is an open source, that means free, scripting language for working with data. And because R, if you compare R to something like Excel, R is extremely efficient and reproducible, especially because using R, you separate your data from your analysis, and all of your analysis is kind of encoded in a script, meaning it is much easier for anyone to edit it, reproduce it, look at it again 6 months later, whether that's like someone you work with or yourself when you have forgotten all the things that you swore you would remember. It's really nice to kind of have a written memory of all the data analysis that you do. We're not going to go too deep into how to physically get started with R, but I have a couple of resources here. You need the R language as well as an IDE, which is just some kind of software on your computer that actually allows you to run R commands, do things with the language that you download. I recommend RStudio. It's kind of by far the best IDE. Some people with particularly advanced needs like other tools for various purposes, but if you are a beginner, I can almost guarantee that RStudio will cover what you need. Both are free to download, and I have also included, again, a link. All the links are on the slides and on the website, just to a helpful installation guide if you are a true beginner and don't have R installed yet. So we use R via packages. And I like to kind of think of packages as apps on your phone. So there are certain things that come ingrained in your phone, right, that you can do without downloading any apps. The kind of analog to that is base R. There are some commands, functions, syntax that you can use in R no matter what. But just like with your phone, you probably want to have some app to check your email and have your calendar and download WhatsApp and like all the various different apps that you want. Same with R. There's probably other things you want to do. And so you can download those packages in order to access the functions that you need. Because packages are essentially just packages of functions, data, kind of other data relevant things, but they're mostly about functions. And functions themselves are just verbs, just what you want to do with data. Mutate, filter, summarize, all verbs that you will become familiar with. And one of the things that is so nice about the Tidyverse, which we'll get into shortly and why we like it and why it's so beginner friendly, is the functions are in fact just verbs, common verbs that you are used to. It makes it very easy to read and learn code. We're going to see lots of examples of all of these, but just to, again, make sure you're familiar with the syntax of a function. You always start with the function name and then argument or arguments to function, whether that's calling data or columns or other various optional arguments would go inside the parentheses, and they're separated. Multiple arguments are separated by commas. Excuse me. So why the Tidyverse? The Tidyverse, which is actually made by the same people who make RStudio, the IDE. The Tidyverse acts as a package, but it's actually a set of packages, which is efficient because you just download and install one package and you actually get 9, which we'll talk about. But it's an opinionated set of packages that kind of work together and are designed for common data science tasks. I like to say that for most beginner and intermediate users, the Tidyverse is going to cover really the bulk of what you need in order to clean your data, aggregate, analyze, start to visualize your data. Of course, when you start getting into modeling and maybe some more kind of advanced topics, you will, just like you accumulate more apps on your phone, you will accumulate more packages that you use. But the Tidyverse is a great starting point because it is so broad. So when I say that the Tidyverse is opinionated, that means that the set of packages have some opinions on the way that your data should be structured in order to use it efficiently. And this is known as tidy data, hence the name of the package, the name of this workshop.
etc. And later in the workshop, we'll talk about tidy data. We'll see some examples of untidy data and how Tidyverse has really helpful functions that allow us to turn untidy data, which is very popular, into tidy data that you can work with more efficiently. So as I mentioned, the Tidyverse itself is actually multiple packages. There's 9. I have 8 listed here because I had not updated my package before I took this screenshot. But there are actually 9 packages that are downloaded as part of the Tidyverse that cover dealing with string data, dealing with factors, package to visualize data, manipulate data, etc. And the 3 packages that we are going to most focus on today are ggplot, which is for visualizing data, tidyr, which is for tidyr, which is for making tidy data, and dplyr, which has all the common functions that you might already be familiar with if you have some Tidyverse experience. Probably the most popular Tidyverse functions, just to how commonly they're used, that are used for data manipulation. And then I mentioned there are actually 9. The newest brand new core package in the Tidyverse is lubridate, which is useful for working with dates. We're actually not going to cover a lot of date work today, but lubridate is a great package to be familiar with if any of your data is dealing with dates, which can be annoying. So those were the 9 core, what they call the core Tidyverse packages, but there are many other packages that are affiliated with the Tidyverse. They're just not all packaged together and attached when you use the library command to attach the Tidyverse. I've listed them here. Some of them may be familiar to you if you, again, have any experience with the Tidyverse, but these, again, follow the same common syntax and opinions of the Tidyverse, but you would need to load them separately. And we're not going to talk about any of these during today's workshop. All right, so I mentioned that dplyr is probably the most common and perhaps the most popular Tidyverse package just because you use these functions so much. And just to kind of cover my bases, I am going to mention what packages lots of these functions are from, that like these are from dplyr, for example, but you don't need to know that because again, once you load the Tidyverse, you load all of these packages and you have access to all of these functions. So you don't need to remember for any coding purposes that, the count function is part of dplyr. But just for ease, I'm going to include that information where I can. So as I mentioned, these are probably the 6 kind of core common Tidyverse verbs that cover a lot of what you need to manipulate data. Again, you can filter to keep rows, select, discards columns, you can sort your data, tally, aggregate, create new variables, etc. And these 2, mutate and summarize, can both be further modified by adding a group function in order to, again, either create new variables or aggregate data based on groups that you specify. And so we're going to go through throughout the workshop today, in which we're going to look at some sample data and kind of answer a bunch of questions about it and make some plots about it. We're going to end up touching on all of these dplyr functions. And again, just to go over a couple of common operators. Again, if you're familiar with R, if you're familiar with the Tidyverse, this might be a bit of review, but in case you're new, the left pointing arrow is the assignment operator, which is what we're going to see it today is generally when you're assigning a new data frame, which is kind of how data sets are stored in R. So I like to think of it as a save as. And the shortcut for that, because you will never want to, you're going to type it so much, you will need the shortcut. It's option and then the hyphen or the minus sign. And also the pipe. The pipe is my favorite operator, the most useful common operator, allows you to chain multiple functions together. So it basically, we'll see this again throughout all of the code in today's workshop. And it sounds more complicated than it actually is. It really just makes your code a lot easier to read and write because you can run entire chunks of code together by, again, piping the output of one function automatically into the input of another function. And the shortcut for that is Command Shift M, if you're on a Mac, that is. So if you're familiar with the Tidyverse, you might be familiar with the Tidyverse pipe. This used to be the only pipe
in R. You would have to load the Tidyverse even if you just wanted to use the pipe. But there's a new pipe, this kind of first one that I have shown here with the bar. And that pipe lives in base R. Again, think of like the operating system on your phone. So it's applicable everywhere and is a little more versatile. So there are some very slight differences between the two pipes, way beyond what we need to discuss today. But for your purposes, they can be interchangeable. I personally am trying to get used to the new pipe after many years of using the old pipe. So all the code you'll see today is using the new pipe. And if you're also in a similar situation, trying to get used to the new pipe in RStudio, you probably use the shortcut to create the pipe, the Command-Shift-M, which is probably the key position that my fingers know the most. And in the global options in RStudio, you can change it. So that command, that same shortcut that you're used to, will just put in the new pipe instead of the old pipe. So, but again, in all of this workshop, it's totally interchangeable. If you're more familiar with the Tidyverse pipe, that's fine. They will do the same thing. So the data that we're going to use today is from Tidy Tuesday, which, if you are not familiar with, is kind of a weekly social data project based in the Tidyverse ecosystem. Again, I've linked to it here. It lives on GitHub. It's big on Twitter. There's a new data set that's released every week, and people can practice data manipulation, generally geared more toward data visualization. But it's also just a great, particularly if you're learning, if you're looking for data for maybe school projects, it's a great repository of lots of interesting data. And so the data that we're going to use today actually comes from the American Kennel Club. So it's data about dogs, which is always fun. Everyone loves dogs. And so to get that data, again, this is the beginning of our code. So convention is at the top of your script. You should always load any packages that you will need in that script, which again is helpful for you or maybe someone else reading your code. And packages are loaded with the library function. I go into detail a little bit more of this on like the website for this workshop. You have to install packages before you can load them. And then once they're loaded, you can freely access all of the functions within that package. So for today's workshop, again, we have loaded the Tidyverse package. And then I'm going to import both of my data sets. We have two data sets that we're going to work with today. We have breed rank and breed traits. And both of those live on my GitHub, like on the GitHub repository for this workshop. So you can use read CSV, which is a function from the Tidyverse, as almost every function we'll see today is, with a couple of exceptions. And read CSV is very flexible. It takes in, gives you the ability to import files with a lot of different file formats, including just a URL. This is just the straight URL for where these files are saved on GitHub, and you can use read CSV in order to bring them into your environment. And we're using, as you can see, the assignment operator here, again, to assign data frame names. So the first data set we have is called breed rank. And just to kind of be clear, these original data sets, I think, have about 195 observations in each one. So not huge data, not what you would call big data, but bigger than I can show you on my screen. So most of the kind of tables I'm going to show are meant to illustrate just kind of the first several rows of the data frame. So when you're looking at these, perhaps on your own computer now or later, don't be surprised if your output shows 195 observations. I'm just kind of truncating this to make it easier to see. But anyway, so we have one row per breed, and we have however the American Kennel Club determines the popularity of each dog breed for each year from 2013 to 2020. And we also have a separate data set for the same set of breeds that looks at 16 different traits, possible breed traits. Again, I just have a subset shown here. And all of those traits are scored from 1 to 5. And if you're personally curious, you can I did link to the original source of this data from Tidy Tuesday. And there's a whole separate data set that actually will show you what the various 1 through 5 scores mean. So per the Tidyverse style guide, variable names should be in snake case. That means that they are lowercase and separated, words are separated with an underscore. If you have a case like this, where obviously our data is not, like this variable name is 2013 space rank. If you have spaces in your data sets, you have to refer to those variables within backticks, which gets kind of annoying. Makes your data a little harder to read. It's a little more annoying to write code. So I am embarrassed that the second function I'm showing you is not from the Tidyverse, but I promise it's the only one. And it is important enough that I think it deserves a mention. The janitor package, as you might be able to guess from the name, holds functions that are extremely useful for like raw cleaning of data. And one of those is called the clean names function, which just takes all variable names and puts them into snake case, which again, saves so much time so you don't have to rename all of those variables on your own. So here again, because I want to use that package, I've loaded it here. And I'm using the assignment operator again. Remember, we can think of this as save as. So essentially, I could save this to a new data set, but I'm not. I'm just going to overwrite my existing one. And I'm going to apply this function in order to clean all the names. And again, this is just a subset, but now you can see all of the variable names are in lowercase and the spaces are replaced with underscores, much easier to handle. So these are the 16 breed traits that are included in the breed traits data set. And today, because we're dealing with tidy data, we're going to look at some very untidy dogs. So all of our analysis today is going to focus on 3 of these traits: the shedding level, the coat grooming frequency, and drooling level. And again, these traits are scored on a scale of 1 to 5. So for example, a dog breed with a shedding level of 5 means there's a lot of shedding. It is a very untidy dog. So these are going to be the traits that we're going to focus on for some of the questions that we're going to answer and some of the plots that we're going to make today. So when it comes to verifying your data, you might be, depending on the type of data that you're working with, you might know it inside and out and be extremely familiar with it. Or if you're working, say, with a new data set from the Tidy Tuesday repo, you might want to actually figure out what this data is all about. The view function, which is a base R function, if you type that into your console, it will pop up kind of a spreadsheet looking data frame in RStudio. That's, especially if you have a smaller data set, and especially if you're familiar with working with data in Excel, you might feel better if you can actually get your eyes on the rows and columns, which highly recommend. Always do that. But there's also ways to kind of programmatically look at our data. And one of the most useful ways is with the count function, which I mentioned is kind of one of the core dplyr functions. And count just aggregates your data at the level of the variable that you specify and gives you a count of the unique, of the unique values of that variable. And I want you to notice that here we don't have an assignment operator. We're just the only text on kind of our first line of code is the name of our data frame. And so that is indicating that we're not actually saving this output anywhere. If you type this, whether it's in a script or in the console, the results, which look like this, will just pop up in your console. If you wanted to save this for whatever reason, you would have to, again, add an assignment operator and actually assign this to a data set. But a lot of times, at least personally, when I'm looking at data, I don't really need to save the output. I just want to look at it. So if we do that, we see we have a lot of these make sense. You know, for the shedding level, we have 41 dog breeds that have a shedding level score of 2. But it looks like we have one breed that has a shedding level of 0. And if you read the data documentation that's available for this data, the variable should be on a scale of 1 to 5. So this might be an error and probably indicate something that we should look at a little bit further. So to do that, this is also a good example of how the pipe works to kind of chain commands together. So I'm going to filter. I'm going to, again, we're not saving this anywhere. We don't have an assignment operator. I'm just going to filter. I want only the observations in which the shedding level is equal to 0. And we know from this that there should only be one. There should only be one observation that pops up here. And remember, filter allows you to keep or discard rows, and select allows you to keep or discard columns. And again, these are the only columns we're interested in, remember? So I'm just going to select those. And looks like this. So we have this one breed plot hounds. And it looks like their data got entered either incorrectly or it's missing or something is wrong. But we should probably, we've made the executive decision that we need to get rid of this row from our data. Which is sad because I had to look up what a plot hound looks like, but they're quite cute. But we are going to have to eliminate them from our data set. So you'll notice that here we do have an assignment operator. That means I am making a change that I want to save that I can access later. So again, we're just going to overwrite this data set and I'm going to filter, and the filter means keep. So I'm going to keep all of the observations in which the shedding level is not 0. The exclamation point means not. So this, again, that the criteria within the filter function, shedding level does not equal 0, basically returns a Boolean, a true, false, for every observation and keeps only the ones for which this is true. So we will end up, we started with 195 observations. We're just getting rid of 1, so we'll be down to 194. And so if you run this code and then run our count again, you'll see that that NA record is gone. So now our data from our perspective, for this purpose, looks pretty clean. So again, I mentioned that we are interested in these untidy dogs by focusing on these 3 traits. So to do that, we're going to use the assignment operator again, but we're going to create a new data frame that's based on our original traits. But again, it's always good to keep your raw data separate so you don't make any big overriding mistakes. And we're going to create this new data frame called untidy scores. And we're going to use mutate, which is another common, one of the 6 common dplyr verbs used to create new variables. And we're going to create a new variable called the untidy score that basically adds together the scores of the 3 traits that we're interested in: the shedding level, the coat grooming frequency, and the drooling level. And then remember, filter keeps rows, select keeps columns. I don't need to keep all of those other traits because for this purpose, I only want to keep the breed and their untidy score. So here we go again. This is just a subset. We have 194 observations, remember, but now we have a very small data frame that just has 2 variables, the breed and this untidy score that we have calculated. So another easy way to kind of look at your data is using the arrange function, which just sorts data. It's the easiest dplyr verb. It's not always super useful. It can be helpful just again for learning, looking at your data. So if we arrange default to ascending order, so if we did this, again, we are not assigning this anywhere. This will just show up in your console. We can sort our data by the lowest untidy score, which basically means these are the tidiest dogs. I have not even heard of some of those dogs, but I guess it's good to know that Chihuahuas are a tidy kind of dog. And then again, we're interested here in the untidy dogs. So you can also wrap, this is kind of our first example of a function within a function. Our argument within a range is wrapped in its own function. So we're going to use untidy score again as our variable of interest, but we're going to look at that descending. And we can see Bernese Mountain Dogs are kind of among our untidiest dogs. So we have all these scores, and can we plot them? So as a reminder, this is only a subset of the data. We have 194 observations. I'm just generally showing you a small subset so that we can fit things on the screen easily. But if we want to plot them, we should probably actually we're going to create a whole new data frame called untidy dogs that filters just to the top values. And another nifty function within dplyr is called slice max that again filters your data, keeps only certain records based on the criteria that you provide, based on the values of a variable that you provide. So this has 3 arguments. Remember, arguments within functions are separated by commas. The first argument is what variable are we interested in? We don't have a lot of variables in this data set, but again, we're interested in the untidy score. And because this is slice max, there's also a slice min if you would rather take the bottom. We're interested in the top untidy scores. We want the top 6. That's our second argument, n equals 6. And then last, this is an optional argument. And And we're basically just saying we want to ignore ties because we only want the top 6, and we again want to ignore the ties. So that will lead us to this data set. Very small. It only has 6 observations and 2 columns, but we can create a little bar chart with this. So before we talk about the specifics of this bar chart, I want to talk a little bit about the data visualization piece of this workshop, because data visualization is a really underrated, I think, part of data exploration and data cleaning. Visualizing your data can tell you a lot about it. And so we're definitely going to focus on data visualization as a big part of today's workshop. And we're going to look at how to create like 5 different graph types. And so for each one, again, in the slides and on the website that is associated with this workshop, we're going to talk through making the most basic out-of-the-box ggplot. Again, ggplot is the Tidyverse package that you use for data visualization. And we're just going to, again, talk about the structure to make these super basic plots. These can be really useful, again, if you're learning, obviously, and if you're just doing personal data exploration. If you're just visualizing data in order to learn more about it, your charts don't need to be beautiful if no one else is going to see them. But once you start, as you can see, you'll see the default ggplots are not that attractive. But thankfully, ggplot has dozens and dozens of functions that make it pretty easy to customize your charts any way that you want to. So again, in today's workshop, we're mostly just going to talk about the structure of the basic data set. But for every chart, I also have created kind of a nicer, slightly more custom version that uses more features of ggplot. We're not going to talk through these as much just because you could do a whole class or a whole course. I taught a whole full-length undergrad course just on ggplot. You can go really deep on ggplot. But I want you to know that the examples are here for you, particularly if you already know how to make basic charts and you're looking, to learn a little more about making custom charts. And all of the code that makes these charts is, again, available on the slides and on the website. So you can look at that later if you're like, oh, how did you order the bars and put the label where you put it? All that information is there. But again, when we're talking about the structure and how to create them based on ggplot functions, we're just today mostly going to focus on these basic versions. So that very long disclaimer aside, again, with a ggplot, we're going to start with the name of our data set, our untidy dogs data set that we just created. And the first line in a ggplot is always the ggplot function. And this provides the basic mapping of your aesthetics. That is, where on the plot, like what aesthetics of a plot do you want to associate with what variables that you have in your data set? AES stands for aesthetics. So here again, this is a very small data set. We only have 2 variables. And that one variable, our untidy score, is going to go on the x-axis, and we're going to put our breed variable on the y-axis. So again, the first line is always for kind of mapping where you want your individual pieces to be. And then you can start adding different geom layers that represent how you want the data to actually appear in your plot. So this is a bar chart, the simplest bar chart you can make. We're just using a geom bar layer here. And we have to include, if you're creating this is kind of a quirk of ggplot, the default bar chart just aggregates and counts your data. And so if you don't want to do that, which we're not doing here, we actually want the bars to be a specific length. Like I want the Bernese Mountain Dogs bar to be 11 units long compared to the others, because that's the specific data we have in our data set. So we're going to use the stat equals identity kind of argument here. And that is your ultimate basic bar chart. Only takes 2 lines. Again, this version is very useful if you're just wanting to look at your data, and then you can slowly kind of build up and add more features in order to create a slightly more custom version. Okay, before we move into tidy data, which is kind of our next big topic, we are at about halfway point of the workshop. So I'm going to take a look at the questions I have seen pop up in the chat. So if you have any questions that have popped up, feel free to drop them in the chat now, and I will take a look at them, and we will have a minute. Will the slides recording be available Yes, again, the slides already live on the website that is linked here. And I believe the recording will go on YouTube. Perhaps these slides and some links will also go on the Our Ladies Paris GitHub. Not sure about that. But yes, everything will be available. Okay, that conversation was the only question. I just saw the chat numbers ticking up and it was making me anxious. So if anyone has, I'm going to take just a minute. If anyone does have a question kind of based on anything we have covered so far, feel free to drop it in the chat. Otherwise, we will move forward in just a second to talk about tidy data. Okay, I will take that as a no. Oh, is there a difference in using either type of piping? Also a good question. So there are some very slight differences in the pipes, but I can tell you that as someone who uses R extensively, like all day at work, lots of this kind of extra data science education work I have not run into any differences in using the pipe that affect my work at all. So I know they exist, but I think they are more advanced edge cases that, again, they have not hit me yet. So if you are any kind of intermediate beginner user of R, I don't think they will probably hit you either. That's best I can say. But again, if you're more familiar with the Tidyverse pipe and you prefer the Tidyverse pipe, go ahead and keep using it. That's how I have been. I'm slowly trying to just get more used to using the base pipe just because that's what I'm starting to see more in kind of the open source materials that people are sharing. But the Tidyverse pipe is not going away. And it's totally fine to keep using it. Again, through everything in this workshop, you can use them interchangeably. The identity argument. Yes, so this is a bit of a personal tangent. It's a little bit annoying. Geom is such a nice way to get started in the stat identity. Argument is a bit annoying. Anyway, so it's only necessary in all the examples we're going to go through today is only necessary in the Geom example. And that's because the standard, like the default Geom the standard bar chart will just count, will make a very basic aggregation of your data. If you remove that, like if you remove the stat equals identity and run this, it will tell you, you will get an error that basically tells you that ggplot is only expecting one variable, one categorical variable that then it counts based on your data and makes a bar chart off of it. But again, we have a specific variable that we want to make bars off of. We've already aggregated our data. We already have it in the way that we want it. I don't need any more aggregations done. So to make a bar chart, you need to get used to adding the stat equals identity argument. But it won't come up again in any of the other geoms that we look at today. All right. Oh, one more popped up. Feel free to ignore. So how to show the percentages on the graph instead of count. In this particular scenario, we don't have a percentage because we just kind of have added up scores. But what you could do, as long as you had, I'm trying to think of a good, easy way to explain the example, but as long as you calculated those percentages in your data set, which you can do via the summarize functions, which we'll kind of get into a little bit later, as long as you have a numeric variable that represents the percentage, you can just put that variable, map it on your X or your Y, and you can make a bar chart with percentages instead of raw counts. Again, the stat equals identity is just saying we want to make the bar chart on exactly what we specify. And if you specify, if your variable is a percentage instead of a count, it will create a bar chart based on that. But that's a good question. And again, all of these types, all of these chart types we're going to talk about, again, I've taught a whole course on ggplot. Like you can just keep going and going and going. But thankfully, ggplot is very well documented. If you want to make like a stacked bar chart, you know, that has like colors for each percentage, all you need to do, Googling just ggplot and stacked bar chart will like help get you on your way. All right, so tidy data. So we learned kind of in our previous section that the Bernese mountain dogs are kind of the untidiest of all the untidy. And so we want to look at like, how does their popularity rank change over time? Because we've mostly been looking at these traits data set, but we also have this whole other data set that has the ranks of the breeds. And this is what the record looks like for the Bernese Mountain Dogs. So if we wanted to plot this, how would we do it? It's easy to think like, oh, I would like, if you're thinking about it in your head, oh, I would like the year on one axis and the rank on another, and you could like maybe make a line or some kind of dot plot. But if you actually sat down with this data and tried to graph it, what variable do you put on your X and what variable do you put on your Y? You would pretty quickly get yourself in a bit of a knot. And that is because, again, the Tidyverse is opinionated. ggplot expects and works with tidy data, and this data is not actually tidy. And that's because this is directly taken from R for Data Science, which is a fantastic intro resource that I have linked to multiple times in the slides and on the website. But there are 3 rules that make a data set tidy. Each variable has to have its own column, each observation has its own row, and each value has its own cell. And you might be thinking to yourself like, duh, that's obvious, which is true. But again, sometimes based on the questions you want to answer and the data that you have, even though your data seems tidy and that it seems like relatively well organized and clean, it's not actually tidy according to these principles. Again, if we look at this, how does this violate the tidy data rules? So what we have shown here is we have one observation for breeds. And again, tidy data rule number 2, each observation must have its own row. This would be fine if we were interested in looking at things at the level of the breed, but this one observation is actually 8 observations. It's the rank in 2013, the rank in 2014, the rank in 2015, etc. Because we are thinking, if you're looking at this data, you're probably thinking of year as a variable with multiple options, 2013, 2014, 2015, etc. But the way this data is set up, it's not set up like that. 2013 is a variable, 2014 is a variable, 2015 is a variable. Again, this might be tidy depending on your use case, but for our use case where we want to be able to plot the ranking of these Bernese Mountain Dogs over time, this data is not tidy. But thankfully, the tidier package or within Tidyverse has very useful functions for making data tidy, because lots of the data that you encounter, especially once you get out of, if you're familiar with kind of like beginner workshops and learning resources, a lot of the data provided for you is tidy because it's nice and easy to work with. But out in the real world, lots of data is not tidy. You'll have multiple observations and columns and multiple observations and rows. And so becoming familiar with how to make your data tidy in order to actually efficiently answer the questions that you have is one of the biggest, I think, like keys of becoming proficient with using R and using the Tidyverse. And I have, again, on the website, linked to more. You can get pretty advanced in your pivoting, your making data tidy. And I have links to that because, again, we only have so much time. I can only touch on a lot of aspects of the Tidyverse and not like delve into anything in particular. But in short, this data can be classified as wide data. And often for tidy data, we want it to be long instead, like literally long up and down as opposed to wide across. So what we have, we're going to use the assignment operator. We're going to create a new variable called ranks pivoted that's based on this breed rank data. And our pivot longer function here has 3 separate arguments. First is what variables do we want to pivot? And remember, in this case, all of these 8 variables, we actually want to, pivot them in order to classify the year separate from the rank. So those are the 8 variables that we want to pivot. And then you can easily specify what the names of the new variable should be and what the values should be. And we want the names to be year because we want to classify the year, and then the values are the rank. So it's a little easier once you see it. Once you see it written out. And again, the links I have on the website to learning more about pivoting show some more like graphical representations. Because for some people, very easy, and other people, it takes a little bit longer to kind of get their head around like how the data is pivoting. So I recommend you check those out if pivoting has seemed mysterious to you. But hopefully you can see that in essence, we have turned each observation, remember we had one observation per breed, into 8 rows, because we now appropriately have a variable for year and a variable for rank. And we can clean this data up a little bit more. We're just going to overwrite it. We're going to rename, because remember, this data set we didn't clean with the janitor package. So that's why, to go back, that's why, again, you have to refer to any variables that have a space or start with the number within backticks, which can get annoying. So anyway, so we have our breed is still uppercase, and we're going to want to change that, which we can do with the rename function, which does exactly what it says on the tin. You start, the only hard part of the rename is remembering that the new name of the variable goes first and then equals the old name. So we're going to rename breed, and again, just change it to lowercase. And lastly, remember this year variable that we have, which is the title, it includes this, it just takes the name of the original columns, which was 2013 rank, but I don't need that rank name in there. So I can use, again, another nifty, this is from Reader, another, again, core Tidyverse package, and then we'll just pull out the number part of that variable. So we'll just get rid of the rank text that's in there. And this is a good example of how mutate can also be used to overwrite variables. We are still creating a new variable. It's just kind of based on itself. And that will leave us with data that looks like this. Again, this is just a subset. This is the example of the Bernese Mountain Dogs, but you would have, in essence, 8 rows for every single breed that we have in our data set. So we can return to our question. We know that Bernese Mountain Dogs are the untidiest of all. How does their popularity rank change over time? Now, if you're visualizing how this would work, it's pretty obvious that your year variable would go on the X and your rank would go on the Y, because our data is now tidy and applicable to be used in a ggplot function. So here's our most basic. We're not talking a lot in this workshop about the stringer package, which is part of the core Tidyverse. It has many useful functions for dealing with strings, which is text data. But I did want to bring it to your attention just because, again, they are so useful if you deal with data that has a lot of text in it. And so what we've done here, again, remember, we're filtering, which means we're keeping observations. Remember, we're only interested in these Bernese Mountain Dogs, even though we have 194 other breeds. So our filter argument uses the string detect function, which returns a Boolean. So, which is, again, what we need for filter, like, is this true, yes or no? And the string detect basically returns a yes if the variable that you provide, breed, contains the string that you provide. So I could, of course, also, if I didn't want to do it this way, I could have my filter argument just be breed double equal sign Bernese Mountain Dogs. But if you don't want to type all that out, sometimes maybe your variable name that you have in your example, very long, string detect is very easy. So again, this will return only the records in which Bernese is present in the breed variable. And in this data set, that's only Bernese Mountain Dogs. All right. Remember, our ggplots always start with a ggplot layer to kind of map our aesthetics. And so here, as we mentioned before, we're going to put year on our X, rank on our Y, and then we're going to add a label aesthetic here, just to, again, tell R, yes, I want my rank on my Y, but I also want the rank to inform the label. And geoPoint is a layer that creates points. So very useful if you have this kind of dot plot, or if you have a scatter plot. And the arguments you see here in these two examples are optional, but here I've just increased the size of the points themselves with the size argument. And then geoText creates a label. And vjust is an optional argument, again, to specify the vertical justification. And so that's just puts the number or the label below the dot. And the last thing I want to mention about the ggplot syntax, which is frustrating, is you might have noticed that we use the pipe, right? Anytime we are writing code with Tidyverse. But once you start making a plot, which again starts with the ggplot function, you need to add lines with a plus sign instead of a pipe. You will forget this all the time. I still do. And again, I've been making ggplots for years. But thankfully, when you do forget, the error message you get is very useful. It says something like, did you mean plus? So it is kind of annoying, but you can just think of the plus as the special ggplot pipe. But if you use pipes instead of pluses, it won't work and you will get an error. And again, we have a custom version here. And all of these custom versions use a custom ggplot theme. Themes are what control the base elements of a ggplot, like what the background looks like, where the grid lines are. Basically anything that's separate from like mapping specific variables to specific aesthetics, kind of the visual appearance of your ggplot. This is, again, the basic is kind of the standard ggplot theme. There are some built-in, I think there's like 6 or 8 built-in ggplot themes that you can experiment with. And you can also, especially useful if you need to, present high quality plots for any kind of purpose, you can make custom ggplot themes, which is what I have done in all of these examples. You'll see when you look at these code, they all kind of end with this theme tidy dog that I created. And I do have the code for that is available on the website and later in the slides. If custom ggplot themes are ever something that you want to experiment with, there is an example to kind of get you started. Okay. So we've looked at kind of how to create a dot plot with geo and point. We looked at a bar chart, and we're going to create a line graph now. So with this dot plot, this tracks the popularity of the Bernese Mountain Dogs over time. But remember, we created that data set that found the 6 untidiest dogs. What if we wanted to essentially make a plot like this, but we wanted to show all of those dogs as each dog having their own separate line? So to do that, again, this is the data these are the data sets we've created so far, right? On the left is our untidy dogs data set, which is very small. It only has these 6 dog breeds in it, along with their untidy score. And then we have this ranks pivoted data set. Remember, we're making our breed rank data tidy. And this has, it has 8 observations, 1 for each year for all of our dog breeds. So if we have these 2, I want the data on the right. I want the rank data, but I only want to include the breeds on the left. So thankfully, you can filter. The filter function allows you to filter across data sets, which is very useful. So here again, we're going to create a new data set that's called untidy popularity. Again, we just want the popularity rankings of these untidy dogs, not all the dogs. The previous example, we filtered to Bernese Mountain Dogs, but here we want all 6 of these dogs. And we're going to base that on our ranks pivoted data set, this data set here on the right. And we're going to filter. Remember, the argument within filter is a Boolean. It returns a yes, a true or false for every observation, and only the observations for which that argument or that condition is true are kept. So in essence, what I'm saying here is we're filtering on breed right here in ranks pivoted, but I only want to keep the observations, the breeds that are listed in this other data set. So this example uses 2 other operators that are pretty familiar to get to know. One is in, which just indicates that, again, we want this to return true if the breed is in this other list, one of multiple options. And then also this kind of dollar currency sign here, which is used to refer to a variable if it's in another data set. Again, you don't need to do this if you're sticking within one data set, right? So this chunk of code is based on this ranks pivoted data. So we don't need to specify what data frame this variable is from because it's assumed that it's from the data set that you're starting with. But if we want to refer to another variable, if I want to refer to breed here in untidy dogs, I need to use this $ symbol. So we can check that this filtered the way we wanted it to by, again, doing our count. And this is the extent of our untidy data, our untidy popularity, data set. we have 8 records for 6 different breeds, which is correct. Those are the 6 breeds we wanted, the 6 breeds we had identified previously as our untidy dogs. And remember, we have 8 observations per breed, 1 for each year from the rank data. So now we have the opportunity to, now we have all the data that we need in order to create that line graph that we wanted. So first, remember, we always start with a ggplot line. It's going to be very similar at the beginning to the dot plot that we just created for the Bernese Mountain Dogs. We have our year on the x-axis and we have rank on the y. But remember, we want to group these by lines. We want to create a line graph. So we need to specify that we want the different breeds to be grouped together. And we also want those breeds, which is the same as our group variable, to have different colors. Basically, I'm telling ggplot to create a color palette that's based on breed. And lastly, we were going to add 2 separate geome layers. We're going to add these lines, which again will be based on the group that you specified, as you would expect. And just to, add a little bit of clarity, we're also going to add a geome point layer, just so our lines have some points, make them a little bit easier to read. And this is what your basic, these 4 lines of code would create this plot. Now there are, again, you can go very deep into the weeds on the literal visual aesthetics of your plots, particularly with color palettes and labels and legends, etc. So again, I have shown a couple of examples in the custom version of this graph by applying a different color palette and trying a new, experimenting with kind of a different way to label the plots instead of needing to have a legend. So again, all of that code is available if any of those elements are interesting to you and seem useful to you. All right, so next we're going to move on to kind of another big topic of relational data. So the question that we're going to try to answer here, we're going to make a scatter plot here, is can we plot the average popularity ranking against the tidy scores for all of our dogs? Remember, we have like 194 breeds after we dropped those poor plot hounds. And we have the tidy scores and we have all the year rankings. So can we figure out what our average popularity ranking is and plot that against tidy scores? We already have the tidy scores. We created those earlier. So let's focus on this first part, the average popularity ranking. We're going to create a new data set called average ranks that's based on our ranks pivoted. Remember, that was the breed rank data that we made tidy. And here's our first example of aggregating data by group. This is a very popular combination that you will see a lot if you're familiar with Excel, doing data analysis in Excel. We're basically creating pivot tables here. We are specifying the variable or variables, if you had multiple, that we want to group by. So we want to group by breed, and we want to create a new variable, which you do within Summarize, that is based on an aggregation. So here we're, again, saying that we want to group by breed and we want to create this new average rank variable that is the mean or the average of the existing rank variable, which remember we had a rank variable for every year. So if you group by breed, you're taking the average of all the 8 years of ranking that we have. And this is what that data looks like. That's the beginning of it anyway. And you'll see here we have an NA value, which is interesting. And this is an important quirk of aggregating data within the Tidyverse. So if you go back and look at the raw data, the original breed rank data, you'll see that that not every breed is ranked in every year. Perhaps, I don't know how the American Kennel Club does their rankings, but perhaps they only take the top numbers. They weren't popular enough in a given year, whatever. But the American Hairless Terriers were only ranked in 2020. So they have no ranking data for any of the other years. And if you have any missing data, and you perform an aggregation, the aggregation will return an NA. And that is, depending again on your data, what you know about your data, that could be very useful information. You're like, oh, there is some missing data here. But if you know your data, you're familiar with, like, okay, we know that some of the data might be missing. I still want to take the average of the data that I do have. All you need to do is, again, add this optional argument here of na.rm equals true. And that will essentially remove any NA observations before the aggregation is taken. So if we add that to our data, again, now we get an appropriate aggregate value for our American hairless terriers here. And just from looking at the data, again, they were only ranked in 1 year. So this is their average rank happens to just be the rank they were in 2020. So again, that's the default is to not remove those NA values, which again is helpful for knowing a lot about your data. But if you're comfortable with removing them, make sure you're familiar with that option and use it everywhere that you aggregate data. All right, so these are the two data sets that we have, at least again, a subset of them. We have this average ranks data set that we just created that has 1 row per breed with their average popularity ranking over time. And we also have, again, we created this way back at the beginning, an untidy scores data set that has 1 record per breed with their untidy score. So how do we put these together? This is an example of relational data, which is just defined by data tables, 2 or more data tables that have something in common. Here, the commonality here is breed, right? We have the same breeds in each data set. And again, once you move past like very beginner data analysis, relational data is everywhere, very common. Especially if you're working in any kind of industry, you often have different pieces of data that exist in different tables, different databases, and there's hopefully some common identifiers that you can join on, but you often need to put data together from multiple places. And again, we can do that through Tidyverse, through the join functions. And there are plenty of join types available. Again, I've linked to them here. The left join is a type of mutating join, which again, remember, mutate means to create new variables. So a mutating join links 2 data sets together and brings data from one data set over to the other based on, again, the commonality. And there are, again, many other types of joins. I've linked to them here. But to start, for this example, we're going to use a very common left join. So we're going to create this new data set called tidy and rank that's based on our average ranks data set that we just created with the aggregating. And our left join here, the first argument is always the data frame that you want to take data from, which in our case is the untidy scores. And then the second argument, the by, is to specify the key. And the key is the variable that is, again, the same between the 2 data sets. You can have multiple keys. You can also have keys that have different names. Again, if you're working in real life data, you might have common keys across data tables, but they have various variable names. And you can handle that, again, easily in this by argument in your left join. Now, if you don't specify a key, you don't technically have to. R will just assume that you want any variable or variables that have the same name across both data sets. That might not be correct. You might not want to join on all of the data, on all of the possible matching variables for many different reasons. Your variables might have different names. So especially in a case like this, where our data frames are very small and simple, it would work, but it is convention to please specify your key, both so that you know that you're getting the results that you expect and R isn't making assumptions that don't match your assumptions. And also so that, again, if you're reading your code, someone else is reading your code in the future, it was clear what you were intending to do. So the data, this is a very small subset of it to fit on this page, but this is what our data will end up looking like. We have breed and average rank from our average rank data set. And then we used a mutating join, which mutated a new variable, untidy score, from our other data set that we created. So again, it's always a good idea to check that it worked the way you wanted to. Oftentimes, this might just be by the literal number of observations in the data set. If you're expecting the same number of observations and it doubled, then perhaps something went wrong in your join. But we can check this with a count. Remember, we know that our untidy score, I think we saw the lowest was 3 and the highest was 11. So we would expect all of our untidy scores to be within there. And it looks like we have an NA here. So again, we can investigate that by filtering. IsNA is again another very useful function to know that is commonly used within filter. Again, returns a Boolean, true or false, as to whether returns any observation that has an NA value or a null value of that variable. So if we do that here, it's the plot hounds again. If you remember, we eliminated them, we filtered them out from one of our data sets, but not from the other. So if you do that, again, this variable was present in our average rank data set, the basis of our join, and we mutated based on our other join, and that data had no plot hounds in it. So we end up with this NA here. And again, I don't want this, so we're going to eliminate. We're basically going to do the opposite of this operation because I don't want just the plot hounds. I want everyone but the plot hounds. And we will, again, you can do that by putting the exclamation point in front of it, which just signifies not. And that will leave us, we can run our count again, and all of our data is correct. So now we have 194 observations here. We have the average rank and their untidy score, which means we can plot it. So scatter plots are, very common type of plot anytime you're plotting two numeric variables against each other. But if you have one variable that is an interval variable, like our untidy score is, we only have certain levels of that variable, a scatter plot can often benefit from a bit of jitter to separate the points out a little bit in order to, so you avoid lots of overlapping data. And we can do that here in ggplot, again, starting with our base ggplot function of untidy score on the X, average rank on the Y. And instead of adding a geom point, we can add geom jitter, which is just another type of layer that specifies that we want a little bit of jitter to our points so that they don't all overlap like in a single line. And a common or a useful argument within geom jitter is just how wide you want that strip to be. And here we want to keep them pretty narrow. And again, this is your common base function. And here in the slightly more custom version, I've altered the transparency of the plots a little here, and I have kind of more clearly laid out the breaks of my untidiness score. All right, so we're going to look at one more plot type and one more analysis question, and then we'll be done and we can go over kind of any questions you have over what we've covered today. So our last question, again, remember we have data on rankings, popularity rankings from 2013 to 2020. So could we look at and could we plot which breeds have had the biggest jump in popularity over that time? Remember, this is an example of the data that we have when we created this tidy data. But if we want to look at the breeds that have had the biggest jump in popularity, I am only interested in records that have a year of 2013 or a year of 2020, right? So I can calculate the difference. I want to get rid of everything else. So to do that, we have three different options. All of these options would deliver the exact same results. The first one here, again, we're using our in, which indicates that basically we're looking for observations that have a value that is either this or that or in this list. And we specify this list here. The C just indicates kind of a character vector here. So this would filter to only years that would equal 2013 or 2020. If we wanted to be more specific, this operator here means or. So we could say filter year equals 2013 or year equals 2020. Or our most robust option, which is really helpful especially as you move kind of out of being a beginner and into using R, using code more widely, is to think about the robustness of your code. And that means like if this code changed, like in this example, if we all of a sudden, if we did this for work, if part of your work is reporting on the popularity of dogs, that sounds like a cool job. And you had to create this plot, and then you got more data, and you were asked to create this plot again to show the biggest jump, you would have to manually change this year, right? You'd have to change 2021 or 2022, depending on the data that you had. But instead, you can specify the year equals the minimum value of year, or year equals the maximum of year. So again, all of these deliver the same result. The last one is a little more robust, helpful to start thinking this way. Once you start incorporating R into analysis work that you hope to replicate someday, kind of with either more data or updated data. So you have to change less once you go back and have to rerun code. So we can perform kind of several operations here. So first, again, we're going to start with a ranks pivoted. We're going to create a new data set called rank change. And we're going to use that filter function that we just talked about. So this will leave us with 2 observations per breed, right? We're going to have a row for 2013 and a row for 2020. And before, the data we were using before, that was tidy. That's what we needed because we needed to plot year against rank separately. But in this case, I actually want a separate variable for 2013, or a separate variable for the first year and a separate variable for the last year. So I can plot them separately and calculate the change, which means we need to pivot again. We're going to pivot in the opposite direction. Instead of pivoting longer to make wide data into long, we're going to pivot wider and make long data into wider data. And this only has 2 arguments. We're going to take our names from year and our values from rank. And again, I want to create this new variable called change to actually see what the change is in the ranking. I'm going to filter. Just imagine for these purposes, I only want breeds that were ranked in the top 50 in 2020, just to give us some parameters here. And then again, we're going to use our slice max function, which we used way back in the beginning, that I want to take, I only want to keep the 6, specify here, I only want to keep the 6 observations that have the highest level of change. And that leads us to this data set. Again, we only have 6 observations. And now we have, instead of having a year variable, we now have, again, a variable for 2013 and a variable for 2020 and a variable for the change. And now we can more adequately plot the change that we want to look at. And we can do that with a dumbbell plot, which is a useful plot type for showing change between 2 points. And now I'm going to be honest with you. It is easier to make a dumbbell plot with this geom dumbbell function that comes from ggalt, which is kind of an extension package to ggplot. But I promise that beyond the janitor example, which is so important, it has to be included, we're only sticking with Tidyverse functions. So you can make a dumbbell plot with ggplot too, which will be useful, that we're going to talk through in a second, to learn how to combine multiple geoms and how some different aesthetics work. But if you're making ggplots in the future, I would recommend looking at the ggalt package to make it a little bit easier. All right, so we talked at the beginning how plots always start with the ggplot function, right? To map the aesthetics that you want. Basically, where on the plot are you mapping your various variables? So for the most part, lots of plots, that's all you need. But actually, you can specify different aesthetics within different ggplot layers, points, segments, etc. What you'll see today. Because anything that you specify in this first ggplot function gets inherited by all of the geoms below, which is how we've done it in every plot that we've made so far today, right? We specify X, Y, maybe a color or a group, and those feed down to all of the various geoms that we've added. But here, because again, making a dumbbell plot in ggplot, we have to add all of the different layers together. We have to add a layer for the first point for plotting 2013, for plotting 2020, and for plotting the line in between to create our dumbbell plot. So the only aesthetic that is common between all of those that I actually want in all of my layers is to keep breed on the Y. That's the only one. And that aesthetic will get inherited by all of these other points that we're going to add. And those points will also have their own aesthetics. So here, geom segment, which again creates a line. We can specify where we want the line to start and end, because we want this line again to start at 2013, end at 2020. And we're going to create our points. One will be at 2013, one will be at 2020. Here I've given them a size, and I've also specified that they have different colors. And same with the labels. I have labeled them 2020 and 2013 separately here as well. And in the custom version, I just did a little bit of sorting so that they were ordered by their 2020 ranking. And I also figured out what the midpoint of the plot was, so I could add a little annotation basically that showed the value of the delta from 2013 to 2020. But again, all that code is available here for you. All right, we covered a lot of different Tidyverse topics. I hope that this information certainly was useful, and I hope it's useful in the future if you want to go back and look at the slides or any of the custom ggplot code that's available. I promised that I would share the code for this ggplot theme. Again, it's also in the code file on the website, on the slides. You can't miss it, but this is how I created this Tidy Dog theme for all the custom plots. And I've also shared here, also on the website, of some of my favorite resources. Again, there's only so much we can touch on in the Tidyverse in under 90 minutes. But all of these are really great resources focused on the Tidyverse, where again, you can delve into topics that you find of interest. And as I mentioned, I am more than happy to, if you have specific questions about this data or anything that I did. If we can't, we have a few minutes for questions and I'll look through those right now. But again, if you have questions later, feel free to reach out on Twitter, email me. Again, I'm happy to help with this data. Thank you all so much. I'm going to try to run through and see if I can spot any questions. And feel free to, again, I can stay for a few minutes, so feel free if you have any questions to drop them. I'm going to run through.
I can see wonderful comments from people. Yeah, you did an amazing job. Thank you so much. Yeah.
Okay, this is a great question. Why did I reverse the Y in some of the custom plots? That's a great question. Let me find a good example here. Let's go back to the line graph, maybe? No, yes, okay. So I just did this because, so again, in the standard plot here, the popularity ranking will kind of automatically rank from 0 to 100 going up. But actually, you know, if you think about a popularity ranking, the #1 ranked dog is the most popular dog. So you might want to have those dogs. The higher ranking is actually a lower number. That's what I meant to say. So you can flip. So you can use this scale Y reverse layer here. And that will, again, flip the Y-axis so that the more popular dogs are kind of higher, which is what people might expect, even though it's a lower number, if that makes sense. Yes. Okay, let's see. In your last example, was there a way to generate the min and max year variables automatically as well instead of hard coding them? Definitely. You can do, I actually wrote, I wrote a whole post on my website kind of about how to make your plot code more robust in the eyes of changing of new data. So yes, if I were making this, if I knew I was making this plot and I wanted to make it more robust, I would do a little bit more to not have to hard code like what the lowest year is and what the highest year is, but just for kind of efficiency's sake for explaining, I left this as it is. But yes, you could definitely, you could edit this code and kind of change the variable name so that it would just be like max year and min year. You could definitely do that. All right, I think I have gone through the questions that showed up. Again, if you have any, feel free to drop them, but we are just about at 2:30 my time. Probably people from a lot of different time zones here.
Yeah, thank you so much. Very nice
Awesome.
explanations. Yeah. We'll make sure to share with you the recording video later. Okay, so normally you should receive an email if you have registered on Meetup. Thank you all for attending. Last thing, I will share with you Google form, a short one. So please share with us your feedback so you will be able to improve the quality of the meetups that you will organize. Oh, I was unmuted. And you are welcome to join us during our future meetup. Thank you again, Meghan, and I wish you good night for people because here in Paris it's already night. Yeah, goodbye all. Thank you.